This is going to be part one of two of our video tutorial concerning our Project 5. Uh, Developing services in Rhino, developing patterns in Rhino, bringing that into our CAM software to program for CNC machining to make fun pattern physical stuff. So let's go ahead and start. So we have established a template file for you to use. Okay. And if we look at this template file, it's got a couple different things we want to address first. One is, let's turn this off, is this red box represents the block of the material that we are going to be machining these projects from. If I do a distance command, right, and I go corner to corner, right, we're measuring 6 inches in X, that's there, 6 inches in Y, that's there, 1.95 inches in Z, from there to there. Now this material is a 20-pound high-density foam manufactured by Modulin. This particular piece is a nominal 2 inches thick, but the actual dimension is 1.95, so that's what we are starting with. If we go to this other layer called maximum design size, and we do a distance command for that, corner to corner. All right, this is measuring 5.5 inches in X, 5.5 inches in Y, and 1.9 inches in Z. All right, so the geometry that you're going to be developing is smaller than the 6 inch by 6 inch by 1.95. This is to make sure that whenever we go to cut this, that we actually have material on the outside, on the X and Y outside, and in the Z to be able to cut everything. Okay, so essentially there's a 1/4 of an inch from this red to the orange on the X and the Y, and about 0.05 or a little bit less than the 1/16 of an inch between the top of the material outline and the maximum design size geometry. Okay, and then if we also turn on this minimum level layer, this represents the lowest level that the surface geometry wants to go to. Okay, we don't want the geometry to go lower than this. The idea is whenever we go to CNC machine these, you'll have a surface and then you'll have a pattern. That tool is actually going to be that tool being either the 1/2 inch ball, 1/4 inch ball, 1/8 inch ball, is actually going to be cutting into the surface that gets made. And that depth is actually tool dependent. So the 1/2 inch tool would go the deepest, and it's going to go a half of the radius, 1/8 of an inch. A 1/4 inch is going to go a 1/16. The 1/8 inch is going to go a 32nd. Cutting into the surface that we're making. Okay, so this is just to make sure that the tool itself, based upon the surfaces that you are creating, is it going below this line right here, which is the side view, which is our Z0 plane. We don't want that at all. Okay, so armed with that, this is the edge geometry, the edge condition that I was given. And I was given it from the person that was right here. So person in front of me was right here, this is me right here, and the next person is actually, in this particular layout, is actually going to be here. So based upon the surface that I develop, I'm giving this next person this edge geometry. Okay, and then they would give the next person their edge geometry, so on and so forth. Okay, so this is going to go right there. Okay, now just like everything else that we do in Rhino, there's lots different ways to do what we're about to do. Okay, there's no one right way. So what I'm going to show you isn't what you have to do, but it is a method to follow. Okay, we're going to make some curved geometry for this side, and then this side, and then this side, and then use that to make surface geometry off of. Okay, so I'm going to activate my edge geometry layer, and I'm going to give myself a line from that corner to that corner, and a line from this corner to this corner. All right, so this piece of geometry is giving us not only the edge, but it's also giving us a start condition. If I type in point, a start point here, and then a start point there. Now I'm going to give myself a couple other points. I'm going to say point there, and then a point there. Just randomly put there. Okay. Now I'm going to turn off. I'm going to lock these first so I don't accidentally change anything. And then I'm going to select these 2 points, not the geometry. These 2 points, I'm going to say hide. And then we're going to focus on making curved geometry for this edge condition right here. So I'm just going to go to a side view, not that one, right to the right. And I'm going to do a spline curve. And I'm not going to start on the point. I'm going to start near the point. And if you start getting a whole bunch of snaps, you can either turn those particular snaps off, or if you want, just say disable all. So my cursor isn't snapping to anything. So I'm just going to say start point there, and then we'll say there, to there, to there, to there. Okay. Somewhere close to the points. So then we'll take this, we'll say move, undisable, say move to there, and then we'll take this endpoint and we'll move it right there. All right, now I'm going to say show, and let's do these points next. So I'm going to select these points, and I'm going to say hide. And I'm going to say back to the right, and I'm going to do another spline. I'm going to go disable all there to there. And let's give it a little bit more. Yeah, that's nice. So we'll select that, back to perspective. We'll say undisable. Okay. Now, if we notice this line's going up above. So what we'll do is we'll need to fix that. So we'll say point there, go back to the side. And it's just a little bit, but we want to keep it below. So we'll just, yes, there, good. Okay, back to perspective. All right, so that's 3. So now let's do the 4th. Show. We'll select these points. We'll say hide. We'll go to our front. And then we'll do disable all. Something kind of like that. Right, undisable, move to there, and then move that to there. All right, so let's see what we get. So I'm going to go to Surface. One way we can do it is by through a curve network. So we'll say click Curve Network, select curves in the network. We'll say 1, 2, oops, okay. So actually, before we do that, we need to say explode. Spelling is important. Explode that. And that's just a single segment. Okay. Back to Surface, back to Curve Network. Select curves. 1, 2, 3, and 4. Very, very nice. But if we didn't like this, then we could say escape and start to give ourselves a little bit more manipulation. So let's bring this down. Maybe like that. Right? Curve. So I'm sorry, surface. Curve network. 1, 2, 3, 4. All right. We're above our minimum, which is good. Now, let's say, for the sake of argument, that let's say I don't notice that this is dipping below, or like I have that layer off. All right. Surface, curve network. 1, 2, 3, 4. Right. And then I turn this back on. Right. Oh no, the surface is deviating beyond the minimum. That's when we would go back, remanipulate this curvature to perspective. Surface, curve network, 1, 2, 3, 4. And now it's not like that. Okay, this is perfect. Now, one of the downsides of using the curve network is the only control that you have in the surface creation is on these edges. But another way that we may approach it is by, let's take this, using a sweep to rail. So if I take this and I move it diagonally 10 inches off to the side. If we go to surface, sweep 2 rails, let's say first rail, second rail, sweep shape, second sweep shape. Okay. This is essentially the same as the other one, but one thing we could do is if we just do a line from, let's say, like there to there. It doesn't even have to be completely straight across. Surface, sweep 2 rails, first rail, second rail. Sweep shape 1, 2, 3. Okay. We get a lot more control about where and how and what gets created with that surface. Right, now that was just a straight line. We could do, let's see, we could do, let's do this. Let's do a 3-point circle. We'll say this is our start point, and we'll have perpendicular on. Doesn't really matter. We'll say that's our second point. Go to a side view. Okay, and say something like that. We'll say trim. 1, 2, trim, and trim. All right, surface, sweep to rail. 1, 2, 3, 4, 5. Then we're getting a lot more control, a lot more specific end results. Right? Now you can do. Now the great thing about the Sweep 2 rail is that you can have as many sweep shape curves as you want. This has 3. You can do 6. You can do 10. The more that you have, the more specific the end result is going to be. Right. Now I think I'm probably going to use the curve network one. I'm just going to move this 10 inches that way. And then I'm going to take this, I'm going to put this on design geometry, and then move it 10 inches there. Alright, so at this point, this is the curve that I started with, the edge condition that I started with. This is the edge condition that I'm going to be giving to the next person. At this point, I can give this to the next person so that they can start doing their development while I continue on. Okay. Now, one of the great things about CNC machining is that we actually don't need this to be a closed polysurface. This is actually good enough. But if you were so inclined, what you could do, if we unlock this orange, and we say extrude, activate my design geometry layer, turn that off, select that, extrude up, solid, say trim, and trim. Okay, now, that worked because, the top view, there is no deviation like inside the orange, outside the orange. So the edges are completely orthogonal to the maximum design size geometry that we already created. Right? Then we can say select, select objects, and say join. Right? 2 surfaces of polysurface joined into one closed polysurface. That's great. Doesn't need to be, but if you wanted to, absolutely works. All right. And we are above, in all areas, above the minimum level. That blue plane that we see. So turn that off. All right. Now, we have our surface geometry. We can shift gears and start developing pattern geometry. And again, there's lots of different ways you can do this. I'm going to show you 3 potential ways that you could do it. One of the ways I like to make patterns is by extracting curve information from surfaces themselves. Okay, so if I activate my pattern level and I do a spline, turn off my ortho, it's kind of randomly generated. Okay. Now these 2 lines are just flat, but one of the things we can still do is I can loft from here to here, okay, which makes a fun surface. All right, now, I did this so that I can say extract isocurve. Go back to a top view. All right, so NURB surfaces are surfaces that are mathematically definable. And by mathematically definable, we can also say that there is a curve inside of this surface at any given point that describes the curvature in x and y and Z. Now, we can extract that information, say wireframe. And as I'm flowing along the surface, the curvature changes. Now that's pretty cool. Now, this was just a random clicking. But one way we could do it is if we wanted a more substantially even spacing, I'll do a line somewhere with ortho like that, and we'll say divide, and we'll say by length, and I'm going to guess, but like 0.3 sounds good. Okay, so it puts a 0.3 inches, every 0.3 inches down the line segment. All right, so now with that, if I say extract isocurve, select my surface, and then I just say point, point, point. It's an even spacing as we are flowing along the surface. And as we flow, that curvature subtly changes as we get from one side to the other. You know, another way you can think about this is kind of like a gradient between two colors. All right, so now with this, I can delete the surface. I can delete that. I can move that. And then I can trim around. Now, you could say that this is kind of boring. And I would agree with you. It is kind of boring. So let's do this. Let's go back. And let's play around with this a little bit more. Give it some extremes. Okay, we'll say loft. Okay. And then we do our line. Let me say from there to there. Let me say divide by length. Extract isocurve. Okay. Now, this is going along the V direction of the surface. If I change the direction from V to U, right, instead of going across, we're going along. Right? Now this is a lot less visually interesting, I would say. So we'll say V. Or, you know, if we really wanted to, we could say both. V. We're just going to say V. And we'll go again from point down the list. Now I made this substantially bigger than the block geometry. The idea is that I can, with more information, I can be specific about where I want this pattern to actually go onto the surface. Okay, so I think that's a lot more usable for what we want to do. Say that. that. We'll delete that. This is much more about things being pretty than anything else. This isn't going to save the world. This isn't going to do much, but besides look pretty. Rotating. Oops. Undo copy. One more time. There. Just make this a little bit straighter. Perfect. We'll say something like that. Yeah. That's nice. Okay, so this is the area that we're going to use, and we don't need any more of this. So now I'll say select. I'll say trim. Turn this off, and trim, and trim, and trim. Perfect. And then delete. Oop, missed a spot. Trim. Perfection. All right. Select objects. I'm going to move this diagonally. 10 inches. Okay, so this is pattern number 1. Now, another way we could do a pattern is by doing some more, or doing like an array of curve objects. So if we say circle, and let's stick with 0.3. 0.3. Okay. If I select this, I type in array. We'll make it an array that's 20 inches in X, 20 inches in Y, just one layer in Z, and then we're going to say starting from the center of the circle, and we'll go out this way. Now, we can do something like this, something really big, but I think for this, we're going to have just a little bit of overlap, like so. Oops. All right, one more time. Array 2021, starting from the center, moving out, a little bit of overlap. Okay, all right. Now, that is not going to be big enough. So what we're going to do, let's do it again. So 20, let's do 50, and 50, and 1, starting from the center, moving out with a little bit of overlap. Ah, much better. Much, much, much better. Now, we could just put this right on top of the pattern, or you could have a little bit more fun with it. If we select all this, and we come down over to here, and we click and hold, and then we go down to Cage, Edit. Select Control Objects. We're going to say Rectangle. And we're going to say from the center of this circle to the center of this circle is our cage size. Is our cage size. U points count 4. Let's make that 3. 3, 3, 3, and we'll say 3. 2, 2. That's fine. Oops. Region to edit, we're going to say global. Okay. So now we've got these control points that we can then drag, which then edits the entire assembly. All right. And I'm just going to play with it until I think it is, done. All right, I think that's going to work for us. So if after I'm done with the cage editing, I can just select the cage, delete it, and now these are all individual curves again. So that now, I'm actually going to make sure all this is locked. Okay. Now we're going to do this. We're going to say group. Make sure I don't screw up this. All right, we're going to select all of this. And then we're also going to say group. Then start moving it around. We'll say disable all. And we're going to turn off ortho. All right. Let's say that is really nice. So now I'm going to type in trim. I'm going to unlock my maximum design size layer, choose that as my trim geometry, and start trimming stuff up. Now there's a lot of trimming to do. So we just got to be a little patient. Make sure we get all the little bits and pieces. Do this one. Closer. There we go. There we go. Further up the edge. There we go. And there we go. All right. Now let's delete. Oh, okay. Ungroup. Let's delete all this other stuff. This. Delete that. Oops. That. And that. And that. And that. All right. Lock that back up. Lock that back up. And so that's pattern number 2. off to the side. Now, another way that you can do it is just a whole bunch of kind of random lines. Make sure these go from outside to outside. You know, just have fun with it. Now, the patterns themselves may not make a lot of sense until, or the potential of the pattern may not make much sense until we actually get into PowerMill, until we actually program the cut and we do our ViewMill simulation, right? Which is fine. More than likely, there's going to be a fair amount, or at least some amount of back and forth between Rhino and PowerMill to kind of develop and hone in on a pattern that, you know, is pretty cool. And that's absolutely fine. That's kind of the point. All right. We'll say that. All right, so I'm going to unlock this. All right, and we'll say trim. Oops. We'll say trim, and trim, and trim. Okay, perfect. Lock that back up. Now, if we go to perspective, you'll notice that all of these patterns are actually down below the geometry. That's actually fine. But what I'm going to do is I'm actually going to select all of these and just move them on disable up to here. Right? Now, this is perfectly fine. This is perfectly acceptable. Whenever we get into PowerMill, the specific toolpath that we're going to be using is actually going to take this geometry, this curved geometry, and project it down onto the surface. All right, this is the path that the tool is going to follow as it flows along the surface. So if we take this geometry and we say project, select surfaces, unlock design, and we don't want the whole thing, so let's explode this for a second. Okay. So let's select the pattern geometry, project, spelling's important, project, select the surface. Okay, that's essentially what PowerMill, our CAM software, is going to be doing for us. Okay, so we don't need to worry about doing that. Now, if you wanted to get a better idea about how this pattern is going to kind of look on your surface, this is a great way of doing that. Now, what's going to happen in PowerMill is if we make a tool real quick. So let's say line offset by 0.5, ½ inch. We'll make ourselves a circle from there to there. And we'll say trim. And we'll say line. And we'll say join. Perspective. We're going to say revolve from midpoint down. Right. So this is what a ball mill is going to look like. This is specifically a 1/2 inch ball mill. If I make copy, move this to the side, and we'll do another one. We'll say polyline, go from there, 0.25, and we'll say from there, 0.125, we'll say scale, there, to there, down to there. We'll say from there to there, down to there. Okay, we'll leave that. 1/2 inch end mill, 1/4 inch end mill, 1/8 inch end mill. Specifically ball end mill. Okay, so if we take this and we go to the midpoint and we just bring it down onto the surface. Okay, the tool is going to follow this curvature as it's projected onto the surface. Now we are specifically programming it so that it's actually going to be cutting into the surface, and with a 1/2 inch, that's going to be 0.125, negative 0.125. Okay, and then it's just going to follow along, cutting into the surface. All right. So that's what the 1/2 inch would do. Like this. The 1/4 inch will deviate or cut into vertical from there, negative 0.0625, 1/16 of an inch. Okay, and then we'll move kind of like that. And then the 1/8 inch, there, move vertical, negative 0.03125, or 1/32 of an inch. Okay, so the bigger the tool, the deeper it goes, and then the wider the trough that gets created. All right, the smaller the tool, so the bigger the tool, the deeper it goes, the wider the trough, less kind of like detail-y stuff that we would probably tend to get. The smaller the tool, the less deep it goes, but the narrower width of the trough that gets created, and that's great for detail stuff. Okay, now this will take longer to machine than this will. So the game is, how do you create a design that works for what you want to do? And if cost is a major concern, then how do you get the design at the cost that you are interested in trying to maintain? So I'm going to take these and I'm going to make a new layer. And I think magenta is excellent for this. Change. Okay. Now what I'm going to do is I'm actually going to back up a little bit. So I'm going to select these, copy, back up, back up, back up, back up. I want to get to the time before we projected the pattern onto the surface. Okay. Now,
okay everyone, I apologize for the abrupt edit, but we had to make a couple updates. So, we have made our pattern geometry, and now we need to make a decision about which of these we want to bring into PowerMill. I think I'm going to bring this one. So I'm going to lock everything besides the pattern geometry. Select, move by my distance. Okay. And deselect. Okay, so this is the pattern that I want to export out of Rhino and then bring into our CAM software PowerMill. So what we're going to do is we're going to unlock our material outline, unlock our maximum design size. We're not going to need the minimum level where we're going. We're not going to need the edge geometry where we're going. We'll definitely need the design geometry where we're going. Okay. Everything that we want selected, excellent. Now with everything selected, what we're going to do is we're going to go to File, Export Selected, and instead of Rhino, we're going to export as a .igs. Right, and I'm going to save this to the desktop. And there's a naming convention that we want to try to use if we can. We're going to do your section. So we'll say section 1, your name, and then I'm going to call this PMill geometry. There we go. Call version 1. Come to options. None of these options seem to matter. So if you pick default, everything in theory should work fine. And we're going to say save. Okay. So now that we have exported our geometry out of Rhino, our next step is to move into PowerMill to begin the programming process to help visualize the pattern that we're trying to create. So we will say goodbye for right now, and I will see you in the next one. Cheers.